Today we are discussing the branch and control, the fourth group of the 8085 microprocessor in the instruction set. For this we will discuss what is the difference between a sequential program and a modular program. These are two programming approaches. If we have a sequential programming approach, there a program is written as a whole. There is a program, a main program, whereby the control is or the entire program is written line by line. When we start executing a program and the first instruction is on line number 1, the next instruction will be on line number 2, 3, 4, 5, and we will execute it in the same order: 1, 2, 3, for the first instruction on 1, then the instruction on line number 2, then the instruction on line number 3, and we will progress line by line till we reach the physical end of the program. This is sequential programming approach. The modular programming approach says that the entire program is not written in the same it's not a single program, but it is broken into a main program and certain set of sub-programs, where the main program will call it during the execution in itself. So what happens is, there is one main program and there are certain set of sub-programs. Now when main program will be executed, the control is required to be transferred whenever the subprogram is called. So how the branching of this control happens is we will study in branch and control group. So we've taken an example of a modular program and a main program and a modular program, a very simple example. We have a program which is starting from line number 10, which is stored from line number 10, which is saying on line number 10, input A, 11, input B, 12, jump 20. 20 is the line number where the sub-program is written, which is the name of the sub-program is XYZ, and it's written on line number 20. Here it does C equals to A plus B. Then on 21 it is written print C, then 22 return. So here what happens is, we will understand the flow with taking in consideration the program counter. Then I will be able to explain how the control transfer takes place, how the transfer of control takes place clearly and efficiently. We've discussed it in class also. So now when the execution of this main program starts, the program counter will be holding 10. Okay, because the first instruction of this program is stored onto line number 10. So PC, the start address is it loads, the operating system loads it, and here there will be no operating system. The start address of the program will be loaded onto the program counter. So program counter is storing line number 10. When this program is required to be executed, the microprocessor checks the content of PC, the program counter, and it encounters 10. So it goes into 10, and what does it fetch from here? Input A. When it is fetching input A from here, the instruction written on line number 10, the content of PC auto increments to 11. Now input A will be executed, then the microprocessor will come to PC, will check the value of the PC. What does it get here? 11. Now when it gets 11 here, it will go to 11 and fetch this instruction. When it is fetching this instruction, PC auto increments to 12. Okay, now the instruction on line number 11 is executed. The microprocessor comes to PC, checks the value 12. When it comes to 12, it fetches the instruction written here, and 12 auto increments to 13. When it executes this instruction here, jump 20, what this instruction says is that now the control is required to be transferred to line number 20. So what happens is, PC is storing 13, now the control is required to be transferred to line number 20. So what happens during the execution of jump 20 is, this 13 is stored over stack. Okay, and in place of this, the subprogram, whatever the address is written in the jump, is written here. So 20 I've got into the PC, and since I had overwritten 13, I'm overwriting 13, I will store this 13 here on the stack pointer. So now the PC is 20. After execution of this instruction, when the microprocessor comes to PC and checks the value, what does it get here? It gets 20 here. When it gets 20 here, automatically the control is transferred to line number 20. Now the instruction that will be fetched will not be 13, but the instruction that will be fetched will be the C equals to A plus B, that is written on line number 20. So this is fetched, and when it is fetched, 20 is auto incremented to 21. Now this is executed. When the execution of C equals to A plus B finishes, then the microprocessor comes back to PC and it gets 21 here. Now it will fetch 21, the instruction written on line number 21. It will auto increment, the content of program counter will be auto incremented to 22. Okay, now when the instruction will be executed, like on line number 21 will be executed, the microprocessor will come again back to PC, checking the value what is in PC. So it gets 22 here. When it gets 22 here, it goes and fetches the instruction written on line number 22. What does it get in line number 22? It gets a return, it fetches. And now when this instruction written on line number 22 is being fetched, this is auto incremented to 23. When now CPU executes this instruction, it's a return instruction. Return instruction is a branch and control instruction, as jump 20 was. It's a branch and control instruction. What happens during the execution of return instruction is that whatever was stored onto the stack pointer is overwritten on PC value. So 23 will be written as 30 now, overwritten as the content of the stack pointer. What was the content of stack pointer here? 13 that I stored earlier. Okay, so 13 comes here. Now after executing this instruction, when the CPU comes here, what is the value of a PC? The value of PC is 13, so it goes here. See, from where was the control transferred? The control was transferred from here. And where is the control returning back after the execution of this subprogram? It is returning back here. So when the control is transferred from X, when it's a branch and control instruction, the control will be back transferred to X plus 1. The return instruction. The jump instruction makes the transfer from the main program to the subprogram, and return ensures the transfer back to the main program. If the jump was happened at X, then the return will now happen at X plus 1. So now the next instruction that will be fetched after the subprogram has been fetched will be D equals to C plus 2. This is how branch and control happens. Here I have written another example. I have taken jump here, because it's a category in branch and control, and I've taken call here, call XYZ. This is the label of the subprogram. I've taken the same label XYZ. So as soon as call XYZ will be executed, the control will be transferred to this place, XYZ. XYZ is the name of this subprogram. So the control is actually transferred to 20, the name of the subprogram, which is being called here. So this is how branch and control happens. Now remember this when I'm teaching you the branch and control instructions.